All right, so we're looking at page 95 and 96 in your guided workbook. So again, I'm going to show you the information on the paper first, and then we're going to look at an Excel spreadsheet that's actually doing this information. So this is talking about an amortization chart for a 30-year mortgage. So what an amortization chart means is that when you make payments for a mortgage or a car or something like that, the amount that you pay does not go fully to pay off the balance of your loan. Some of the money goes towards to pay interest, and the rest of the money goes towards the balance of the loan. So, if you pay the loan off early, for example, sometimes the bank will end up owing you money back because you're paying interest, assuming that this is going to be a 30-year mortgage. So here we have an amortization table for a 30-year mortgage. The initial loan, the book says it's 200,000, but all of the pictures and everything deal with 150,000. So we're going to do 150,000, and it's 6% annual percentage rate. So when they set up their Excel spreadsheet, they put the amount of the loan here at B1, the annual percentage rate is a percentage at B2, the term, which is 30 years, at B3, and then they did these calculations. The beginning balance is going to be the 150,000, the monthly payment, the amount of interest that's paid that month, the amount of principal, which means how much of this monthly payment, how much this $899 actually is going to pay off this loan, and the ending balance, which is how much is still owed on the loan at the end of that first month. And then that ending balance comes over here to month 2. Your monthly payment never changes. It's always the same amount based on that percentage rate. And then your interest payment, since your interest is going to change because it's always the same percentage, so we'll talk about that. That means your principal amount changed. So you'll notice here at the beginning that you owed that $750 went to interest and $149 went to principal. But at the very end of the loan, here's month 360, you'll notice that only $4 went to interest and $894 went to the principal. So it changes at the end of the loan. You'll notice the scale changing. So here they're asking you, what would go in cell B6? What would go in cell B6? So we're going to take whatever value we type up here, and that's going to go in cell B6. So the whatever's in B1 is what's going in B6. So that's what we would type right here in cell B6 is the value, the equation equals B1. In cell C6 is our monthly payment. Okay, so our monthly payment is going to be, we're going to use that payment function, and the first thing is our rate, and our rate is located in cell B2. Okay, the number of periods is going to be 30 years times 12, so it's going to be the B3, the 30, times 12. The previous value is what we started with, which is the 150,000. And the future value we eventually want to have 0. Okay. In cell D6, D6 is our interest amount, and the interest is going to be based on the beginning balance times the interest rate. So it's going to be whatever's in B6 multiplied by B2. So it's going to be whatever's in B6 multiplied by B2, but we need that to be our monthly payment, so it's going to be divided by 12. All right, the principal payment. The principal payment is this amount right here. And to get the principal payment, we took the monthly payment and we subtracted the interest. But you have to remember the red means that it's a negative value actually. So this value is negative, this value is positive, so if I add them together, it's going to subtract. So instead of subtracting those two, I'm actually adding them. C6 plus D6 will take those two values and subtract it. It'll take the value of this, subtract this, and that's where I get this. It's a negative number. So the amount of principal is negative. The ending balance is going to be the amount of the beginning balance, and I'm going to take away this principal payment, which is already negative. So I actually end up adding them because it's negative, and I end up with that. So B6 plus E6. And then the beginning principal, meaning at the next month, is going to be whatever's in this value pulled over here. So that's going to be equal to F6. All right, so now if we look at all of this in a spreadsheet, now I did my spreadsheet just a tiny bit differently because what I did on my spreadsheet is I have my monthly payment calculated right here. So you'll notice right here I have the payment B2 sorry, divided by 12, B3 times 3, and B1 times and B0 and 0. The reason I did it here is so that when I drag it down, I don't have to worry about the referencing and making sure I've got the absolute referencing around this. So you'll notice right here what I typed is exactly what I said for problem number 5. There's the equals B1. Now for my monthly payment, I did do it slightly different. I referenced this point right here. Instead of typing the formula in there, I just typed it once. I do have to have the absolute referencing on it because I need to make sure it doesn't change as we go down. The interest payment is the B6 times the B2 divided by 12. The principal payment are these two values added together. And the ending balance is the beginning balance and the principal added together. And then you'll notice that that 149 is over here, so it says equals F6. So here's what happens. As we go through, you'll notice that the interest is 750, the principal is 749. As we go a little bit farther down, the interest is 708, the principal is 190. It's changing a little bit. As we keep going down, this is month 197. The the interest is 502, the principal is 396. And we keep going. And here we have the interest is 100, the principal 797, and at the very end the interest was 447 and the principal was 894, and the loan's been paid off. Okay? Now, on the second page, on page 96 in your guided workbook, it says, how much interest did you end up paying over the 30 years? So I'm going to do it two ways. You'll notice right here, I added all of the interest together. And I took all the values in that interest column and added them up, and I got $173,757.28. So that's how much interest I ended up paying over the entire 30-year period of time. So then the question says, what if I only had to pay 5% interest instead of 6% interest? Well, here's where the spreadsheet is so nice. Here's my interest rate right here. If I just change that to 5%, notice my monthly payment changes. Notice that at the very end here, I got to scroll all the way down, I ended up paying it off here. So notice that I only ended up paying $139,883.68 in interest. So by making one change to my whole spreadsheet, I'm able to calculate something without having to go through and drag down again or highlight things or do anything like that. So another point I wanted to show you here is this is something where naming your cell is very beneficial. So notice that this cell is not named. It just says D2 here. So what if I named it and I called it interest? Oops, I forgot to erase the D2. Okay, so notice I named my cell interest. Instead of naming it D2, I've named it interest. So right here, I could just say equals interest. And notice how it says equals interest there, right? So now when I drag it down, I don't have to worry about did I put the dollar signs or not? Did I reference it correctly? Notice that it dragged everything down. I didn't have to worry about the dollar signs around the D. So sometimes when you're able to name a cell, it's very beneficial when you're trying to drag things down and fill the whole cells. So that's dealing with this. So let's go back real quick to our worksheet, and you'll notice again our last two questions on the back on page 96 said, how much interest do you pay over 30 years? And remember, we calculated it on the spreadsheet by adding them up. But there's another way to do it. If my monthly payment is $8.99.33 a month, and I pay that payment for 360 months, then that means that I'm going to pay, if I do that on my calculator, $8.99.33 times 360, I'm paying $323,758.80. Well, I only borrowed $150,000, sorry. So that means I got the $173,758.80, which is the same number that we got when we did the sum of the interest column. And then again, when we changed it to 5%, it dropped to $139,000, and we saw that on the spreadsheet when we did that earlier. Hope this helps.